Okay, so for the second day here, we're going to solve systems of equations by graphing. So again, what is a system of equations? System of equations is two or more equations, right? A system is two or more equations. And again, what does it mean? What does it mean to solve a system of equations? It is to find the point, right, the x and y that works for both. Okay? It's to find the x and y that works for both. So one way to do this is by graphing. So let's take a look here. Number one, remember we have two different types again. We have slope-intercept form, which was y equals mx plus b. We have standard form, ax plus by equals c. Okay, so again, you ask yourself, if y is by itself, we're going to do that begin and move. If x and y are on the same side of the equal sign, then we're going to find the x and y intercepts. Let's look and see what we have here. So we're going to graph both of these. Let's put this one in red. Well, look at this. It looks like y is by itself. Y is by itself. That means that this guy is in slope-intercept form, so we're going to do begin and move. How about the second guy? Looks like y is also by itself, so it's also in slope-intercept form. Again, we're going to do begin and move. So what is our m? What is our m? What's our slope for this red guy? Well, it's a negative 1, right? Oops. That blocks it, negative 1. Negative 1. You can put that as negative 1 over 1, just to make it a fraction. And what is our b? What is our y-intercept? It is 3. All right, so we're going to begin and move. So start at the x-axis. Here's our y-axis. Begin at this 3 here on the y-intercept. So there it is. And we're going to move. Now rise over run. If it's a negative rise, remember it's not going to be up, it's going to go down. This is still 1 to the right. So it's going to be down 1, right 1, down 1, right 1. Let's go ahead and start from this dot. Down 1, right 1, down 1, right 1. Let's say we don't want to go down 1, right 1 anymore. We can also go up 1, left 1, up 1, left 1. So let's go ahead and draw that in. With as straight of a line as possible. Not like that. Go. All right, and this guy right here, we have our m and our b. So our m is negative 7 over 1, right? Over 1, you can also put over 1. And our b is not 3, our b is negative 3. So we're going to begin at negative 3. Begin at negative 3. Now, we're going to move. How is this going to look like? So it's going to be, again, it's negative, so we're not going to go up. We're going to go down 7, right 1. Down 7, right 1. So down 1, 2, 3. Whoop, looks like we're off the screen here. So you can also flip this. So instead of down 7, right 1, if you change this to be a positive like this is going to become up 7. This becomes a negative, so left 1. So instead of down 7, right 1, down 7, right 1, I'm going to go up 7, left 1. So let's go 1, 2, 3, 4, 5, 6, 7, left 1. And that's really all the space that we have. So we'll just use those two dots and we will connect them. All right, and from that, it's pretty clear to see that these are all my points. Here, 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 here. They all work for the green guy. This one works for the green guy. This one works, this one works, this one works. And of course, the other ones, these work for the red guy, these work for the red guy, these work for the red guy. But there's only one point that works for both of them. That is the solution right here. This is our solution. This is our solution. And the point is, let's see, what is my x coordinate? It is -1, -1, comma, 1, 2, 3, 4. -1, comma, 4. -1, comma, 4. That is my solution. So x is -1, y is 4 is my solution. Now again, we're not going to check all of them, but let's check here to make sure that really works for both. So I'm going to plug in -1 for x, 4 for y. -1 for x, so -1, let me erase that here, for x, and 4 for y. Get that right side up again. Okay, so -1 for x, so -1 and 4. Well, what's negative -1? Negative times a negative is a positive. 1 plus 3. Does that give me 4? Yes, it does. So that works. How about right here? Plug in -1 for x and 4 for y. Plug it in. -1 for x and 4 for y. So what's a negative times a negative? Negative times a negative is 7. 7 minus 3. Does 7 minus 3 give me 4? Yes, it does. So we know that this is a solution that works for both the red guy and the green guy. It's the only one that works for both. All right, let's try another one. Number 2. So again, we look at these guys. Y is by itself. Y is by itself. So it looks like they are both in slope-intercept form. So we're going to begin and move. Call this guy the red guy. So we're going to begin, right? This is my M, this is my B. So we're going to begin here at -1 on the y-axis. So begin here at -1. There it is. And we're going to move. Let me just write this out here. We're going to move and put -1 over 3. You could give the negative up here or down here. You get the same thing either way. So you could say, all right, this is negative, so I'm not going to go up. I'm going to go down 1, right 3. Or you could also go like this. Either way, they're the same thing, and that would be up 1, left 3. Either way, because it's the same thing. So if we go, start from here, go down 1, right 3, 1, 2, 3. Down 1, right 3. Oh, I'm out of space. So instead, let me go up 1, left 3. Up 1, left 3. You get the idea. So that is the top guy. Let's go ahead and draw it in there. All right, and the second one is also in slope-intercept form. This is our M, this is our B. 2 over 1. Our B is 4. Remember, this is the y-intercept, so put it right here. All right, we're going to move. We're going to move down 2, right 1, down 2, right 1, down 2, right 1. You can also go up 2, left 1, up 2, left 1, but that would be going off the screen here. So down 2, right 1, down 2, right 1, down 2, right 1. Oh, I think I found my solution. The point of intersection right there. All right, so we draw it in. Draw our arrows. So again, we look for, these are the ones that work for the green guy. All these points work for the red guy. What is the only point that works for both, their intersection? Right here is my solution. That is my solution. And that is x is 3 and y is -2. X is 3, y is -2 is my solution. Solution has to work for both, the red and the green, top and the bottom equation. So yes, and if we plug it in, I'm just going to write over here, so you'd have -3 and you'd have -2. Let's see if that works. Negative times a negative would be a positive. 3/3 is a 1. Oh, sorry, it's not a -3. Sorry, +3. So 3/3 makes a 1, so you're left with -1 minus 1. -1 minus 1. Does that give you -2? Yes, it does. And if I plug in 3 for this x and I plug in -2 for this y, what is 3 times -2? That is -6. -6 plus 4. -6 plus 4, that gives me -2. Yep, that works. All right, so it looks like we're good on that. So you guys can handle, I think, number 3. Looks like, again, these guys are in y equals mx plus b form. So don't forget to begin and move. You can write out your m, your b for both of them. This guy and this guy and the second equation. Or if you're used to if you can just do it in your head, you could do it that way as well. Looks like number 4 is very similar. Why don't we take a look at number 5? All right, so number 5. Remember here we've got x and y together on the same side. X and y together on the same side. So this is standard form. Standard form. ax plus by equals c. Standard form. Right? When x and y are together on the same side, x and y are together, x and y are together. This is standard form. So remember, this is not slope-intercept. We're not going to begin and move. Rather, we're going to find the x and y intercepts. X and y intercepts. So first off, let's find the x-intercepts for the top guy, the red guy. Now remember, our shortcut, you can just do c over a, c over b. But let me remind you just the other way, in case you forgot. The other way to find it, instead of doing c over a, c over b, is to plug in 0. So to find the x-intercept, you're going to plug in 0 for y. All right, so plug in 0 for y right here. And we're going to get, this becomes 0, we're going to get x, oops. We're going to get x equals -6. So your point is going to be -6 comma 0. -6 comma 0. All right, our y-intercept is going to be same thing, except you're going to plug in 0 for x. Right, you're going to put in 0 for x. Plug in a 0 here. So that becomes 0. And we get 2y equals -6. We divide to get y by itself. Divide both sides by 2. Get y equals 6 divided by 2, which is 3. We get -3. All right, so let's go ahead and graph that. Let's go ahead and graph that. So this is our x-axis. This is our y-axis. -6 comma 0. -6 comma 0. So in case that this doesn't have enough, you guys can just kind of take your best guess. -1, -2, 3, -4, -5. Try and make it like right about there. That's okay. We'll just guess where it should be, right about there, -6. And then 0 comma -3. So 1, 2, 3, 0 comma -3. All right, that's our x-intercept, our y-intercept. Let's go ahead and try to connect these guys. All right, draw the arrow in. All right, now, so remember you can plug in 0, but the shortcut, let's do the shortcut method with this one, and that is to use A, B, and C, just like standard form uses, A, B, and C. A is the number in front of x, the coefficient, B is the coefficient of y, and C is the number over here. So it looks like A is 2, looks like B is -1, and it looks like C is -2. All right, so the shortcut to find the x-intercept, you just do c over a, right? C over a. So negative 2 divided by 2. Negative 2 divided by 2. And since 2 divided by 2, that's just 1, so we're just going to get negative 1. So our x-intercept is negative 1, or the point negative 1 comma 0. Negative 1 comma 0. All right, let's go ahead and put that on our x-axis right here. For our y-intercept, we're going to do c over b. C over b, so that's going to be negative 2 over, and b was negative 1. So we're going to get 2 over 1, which is 2. A negative divided by a negative is a positive. So we're going to get 0, comma 2. 0, comma 2. For our y-intercept. So 0, comma 2 up here. And we'll go ahead and do our line, straight edge as best we can through both those points. Alright, so these are all the guys that work for the green. These are all the guys that work for the red. I think you can see which is the point that works for both. The solution right here. Alright, that would be negative 2, comma, negative 2. X is negative 2, y is negative 2. There it is, our solution. Negative 2, negative 2. Negative 2, negative 2. X is negative 2, y is negative 2. And if we plug that in right here, negative 2, plug in negative 2. So if we multiply, so 2 is multiplied. 2 times negative 2 is negative 4. Negative 2 minus 4, does that give me a negative 6? Yes, it does. Plug in a negative 2 here. This should be multiplying here. Negative 2. Sorry, it's kind of sloppy. 2 times negative 2 is negative 4. Negative 4, and that's a minus, right? Minus and minus turns into a plus. What is negative 4 plus 2? Negative 4 plus 2, different sign, subtract. Take the sign of the bigger number, we get negative 2. Yep, that works. So it works for both of them. This is our solution. Alright, so we are on the back, solving systems by graphing. You guys can handle, I think, these guys. Don't forget number 8. Looks like you only have one variable here, number 8. So think about whether it's going to be a vertical or horizontal line. If your y value, your up and down value, is locked at 3. But I'll let you tackle that. Right now I want to take a look at number 11. We'll do number 11 and 13, and that'll be it. So number 11, first of all, we have to decide, is this going to be slope-intercept or is this going to be standard form? Slope-intercept, so is y by itself? Is it y equals mx plus b, slope-intercept form, begin and move? Or is it ax plus by equals c, standard form? And here we see x and y are together on the same side. So it is standard form. It is not begin and move. We're going to find the x and y intercepts. We're going to find the x and y intercepts. So let's go ahead and do that. The x-intercept. We will use the shortcut method. Don't forget you could do the plug-in 0, but we're going to do shortcut. So to find the x-intercept, we just find a, b, and c. Remember our a is just a 1 here. A is 1. So the x-intercept is just going to be c over a. So that's going to be 6 over 1. So 6 comma 0 is the point. Let's go ahead and label that x-intercept. This is our x-axis. This is our y-axis. Well, it looks like we're going to go off the graph again. That's okay. Let's just do our best guess. So 1, 2, 3, 4, 5, and then try to do the same distance right about there. 6. Okay, and let's do our y-intercept. That's going to be c over b, shortcut c over b, so it's 6 over 2. 6 over 2, 6 divided by 2, of course, is 3. So our y-intercept is 0, 3. 0, 1, 2, 3, right there. All right, so let's go ahead and graph these guys. Let's see if we can graph it. Yes, we can here. Go. Don't forget your arrows. All right. Now, the green one. Again, we have only one variable. X equals -2. When it's just X, remember, it's either going to be a vertical line or a horizontal line, when it's just X or just Y. I want you to think about it. Since X represents the left and right value, right? The left and right value, what would it look like? Let's go ahead and put X equals -2. This is the X-intercept, -2, right? This is one possible point. Where are the others, though? Well, if my left and right, X is left and right, if it's locked, it's always -2. If my left and right value is locked at -2, I can't move left, I can't move right, I'm stuck here. I can only go like this. At every point along this line, up and down, my X value is -2, right? This is -2, 1. This is -2, 2. This is -2, 3. This is -2, -1, and so on and so forth. You don't even have to draw the dots. Just know that it's always going to be a vertical line when you have X equals, and it's always going to be a horizontal line when you have Y equals. So you can go ahead and draw that in. All right, all these guys work for the red. All these guys work for the green. Where's the only point of intersection that works for them both? Right there. All right, what point is this right here? That is X equals -2, which makes sense because it has to be X equals -2. And Y equals 1, 2, 3, 4. So -2, 4. This is our solution. X is -2, Y is 4. X is -2, Y is 4. And let's just try that real quick. X is -2 and Y is 4. What would that be? -2 plus 2 times 4. 2 times 4 is 8. -2 plus 8. -2 plus 8. Does that give me 6? 8 minus 2, yes. And there's no Y to plug in. I just plug in -2. Does -2 equal -2? Yes. So this is the only point that works for both the green and the red. All right, let's try one of these guys here. It says, is -1, 5, right? This is my X. This is my Y, a solution to this system. Remember, solution means it has to work for both, not just the top one, not just the bottom one. It has to work for both. So all we got to do is plug it in and check. So let's plug into this guy. What do we plug in for Y? Well, we're checking this, right? Go and plug in a 5 here. So 5. I'll use parentheses just to show that I plugged it in, equals, so question mark, 2 times, what's my X? Looks like it's a -1, right? -1 right there. Plus 7. All right, does that work? Well, 2 times -1, that's -2 plus 7. Does that equal 5? 7 minus 2, that equals 5. Yes, that does work. All right, let's take a look here. How about this guy? Let's rewrite this out. So 4 times, this looks like it's in standard form. This one's in slope intercept. 4 times, what do I plug in for X again? -1 plus Y. What do I plug in for Y? 5. Does that equal, I'm going to put a question mark here, does that equal 1? Well, this is -4 plus 5. Does that equal 1? -4 plus 5 does indeed equal 1. So it works for the green one, and it works for the red one. So if it works for the green and works for the red, it looks like this is a solution. So we can just say yes. It's a solution. Yes, it's a solution. Works for both. All right, you guys should be able to tackle this one as well. Just remember, this is your X, this is your Y. Plug it in to see if it works. It has to work for both. All right, go ahead and finish the rest of these.